During these 6 years, my team and I have explored new paths in semiconductor and found a way for sustainable evolution.
Imagine getting banned from attending the classes and still topping the exam. How? Since 2019, Huawei has been locked out of the machines behind 90% of cutting-edge chips. Now it's back with a chip that has the entire semiconductor industry paying attention. When export restrictions were announced in 2019, many experts believed Huawei's semiconductor journey had reached its limit. The reason was simple. Modern processors are built using extremely advanced lithography machines made by ASML, a Dutch company that is currently the only manufacturer capable of producing the world's most advanced EUV systems. Each machine costs well over $350 million, weighs nearly 180 tons, and contains more than 100,000 individual parts. Without access to these tools, the common expectation was that Huawei would slowly fall further behind companies like Apple, Qualcomm, and MediaTek. Every passing year would widen the technology gap. At least, that was the prediction. Instead of chasing smaller transistors, Huawei asked a different question. What if performance could improve without shrinking them further? For over 60 years, the semiconductor industry measured progress in nanometers, where smaller almost always meant faster and more efficient chips. Huawei shifted its focus to something entirely different, reducing the distance electrical signals travel inside the processor. For decades, the semiconductor industry followed Moore's law, an observation made in 1965 that predicted the number of transistors on a chip would roughly double every 2 years. Surprisingly, that prediction stayed remarkably accurate for almost 6 decades. Early computers filled entire rooms and performed only a few thousand calculations every second. Today's smartphone processors contain more than 20 billion transistors and perform trillions of operations per second, all from a chip smaller than a postage stamp. Every improvement in computing, from gaming to artificial intelligence, benefited from this steady progress. It became one of the longest-running success stories in engineering history. But no trend lasts forever. Modern transistors are now measured in just a few nanometers. To understand how small that is, a single human hair is about 80,000 to 100,000 nanometers wide. If a transistor were enlarged to the width of a road, that same human hair would stretch for several kilometers. At this tiny scale, physics begins creating unexpected problems. Electrical resistance increases, tiny wires become harder to manage, and unwanted heat builds up much faster. Even stranger, electrons can sometimes pass through barriers that should stop them, a phenomenon known as quantum tunneling. Engineers are no longer fighting manufacturing challenges alone. They are also fighting the fundamental laws of physics. Many people assume today's processors are becoming slower because engineers have run out of ideas. The reality is much more interesting. Modern transistors already switch incredibly fast, but the electrical signals connecting billions of them often take longer to travel across the chip. In advanced processors, these tiny communication delays can become 10 times longer than the time needed for the transistor itself to switch on or off. This is one reason why smartphone processors have remained close to 3 to 4 gigahertz for many years, instead of increasing dramatically with every generation. The biggest bottleneck was no longer the transistor. It was the distance between them. Huawei's solution is called logic folding, and it changes how chips are arranged rather than how they are manufactured. Traditional processors spread billions of transistors across one flat surface, forcing electrical signals to travel long horizontal paths. Huawei instead stacks important logic vertically, so that components that once sat far apart now sit directly above or below each other. The result is a much shorter route for information to travel. According to Huawei, this new layout increases transistor density by around 53% in a single generation, a jump that many engineers believed would be impossible using its existing manufacturing technology. If those numbers hold up under independent testing, this could become one of the biggest architectural changes since modern chip scaling began. At first, Huawei's idea might sound similar to 3D chip stacking, a technology that already exists. Companies like TSMC, Intel, and AMD have been stacking memory and processors for years to improve performance. The difference is when the stacking happens. Traditional chips are first designed as flat circuits and only stacked together during packaging. Huawei claims logic folding starts much earlier, while the chip is still being designed. Engineers identify the longest and slowest signal paths, then rearrange those circuits vertically from the beginning. Instead of simply placing one finished chip on top of another, the architecture itself is built around the third dimension.
That small design change could make a much bigger difference than ordinary stacking. Huawei says its previous chip packed around 155 million transistors per square millimeter, after improving from 126 million over nearly 3 years. That worked out to a gain of only about 23%, showing that traditional scaling was already slowing down. The company's next processor reportedly reaches 238 million transistors per square millimeter, a massive 53% increase in just one generation. For comparison, TSMC's N2 process, one of the world's most advanced manufacturing technologies, is estimated to reach roughly 292 million transistors per square millimeter. Huawei is still behind the industry leader, but it has reportedly closed a large part of the gap without using the newest lithography machines. That is exactly why these numbers have attracted so much attention across the semiconductor industry. Packing more transistors onto a chip is useful only if they can communicate efficiently. Every processor depends on a clock signal that synchronizes billions of operations every second, almost like a conductor leading an orchestra. Huawei claims logic folding reduces the number of clock buffers by nearly 50%, freeing valuable chip area while lowering power consumption. The company also reports a 25% reduction in clock skew, which is the tiny timing difference between signals arriving at different parts of the processor. Even delays measured in trillionths of a second can limit performance. Huawei also says the average data path inside the chip becomes about 60% shorter, allowing information to move much more quickly between important circuits. Can it really reach desktop speeds? One of Huawei's boldest claims involves clock speed. The company says its upcoming processor reaches around 3.1 GHz, an impressive figure considering the manufacturing technology available to it. Looking even further ahead, Huawei believes this design could eventually support 5 GHz mobile processors by the early 2030s. That number matters because today's flagship smartphone chips from companies like Apple and Qualcomm generally operate between 3.7 and 4.3 GHz, while desktop processors from Intel and AMD often reach 5 to 6 GHz, using much larger cooling systems. Achieving similar speeds inside a smartphone without dramatically increasing power consumption would represent a major engineering milestone. Whether Huawei reaches that goal remains uncertain, but the ambition alone has captured the industry's attention. Stacking circuits through logic folding creates a major challenge: heat. More layers make cooling much harder, and excessive heat can reduce performance and efficiency. Huawei also needs entirely new EDA software because existing chip design tools were built for flat, two-dimensional layouts. Solving these two challenges will determine whether logic folding becomes the next breakthrough or remains an experimental technology. For nearly 60 years, the chip industry chased one goal: building smaller transistors. Huawei's logic folding suggests there may be another path by reducing signal travel instead of only shrinking components. Independent testing will decide whether these claims hold up, but the idea has already challenged one of computing's oldest assumptions. If successful, this approach could influence not just Huawei, but the future direction of the entire semiconductor industry. If you enjoyed exploring the engineering behind Huawei's latest chip, leave a like, share this video, and subscribe for more content.